Okay, we are still on application of first order differential equation to electricity. All right. So if you have not watched our first video, you can do that, where we explained and derived some differential equation for circuit that has only resistor, the one that has only capacitor, and the one that has only inductor. So, but in this particular video, we'll be talking about the one that contains two. So the first one we'll be looking at is a circuit that contains uh, resistor and inductor. So we have resistor, inductor, circuit. So you know that L is used to represent inductor, not I. Okay. So we'll now have, let me draw it. Let me have that this is the resistor, right? And then this is the inductor, and then I now have that this is the potential difference E, right? Okay. According to the uh, Kirchhoff's law, Kirchhoff voltage law, it said that the total potential difference across them should be equal to the sum of the instantaneous potential difference across the resistor and across the inductor, right? So if you remember from our derivation that we got that that this E of t, okay, now this particular one is just IR according to Ohm's law, but this particular one is what? This I change to the derivative, that is the I dt, then you still put your R. Okay, sorry, you now put your L, sorry, for using inductor here. Don't forget that. But if it is for capacitor, it will now be integration. I taught you that in the first video, that for resistor is just I, for inductor is the derivative, the differentiation of the I, while the capacitor is the integration of that I, right? It's very simple to remember. Now if you look at this equation very well, let's decide to divide everybody by L. Okay, so it's going to be what? E of L is equal to what? I sorry, R over L I, then plus the I dt. That's dividing everybody by L. Now if I write this very well, it will now look at like this: the I dt, okay, plus R over L I is equal to what? E over L. Now if you look at this equation, you notice that this is what? First order linear differential equation. All right, if you remember first order, if you have not watched my video on differential equation, you should do that. The link should be on the description. All right, so if you look at first order differential equation, you have okay, let me use I and T. You have that you have that okay, let's say that y plus, sorry, dy dx, dy dx plus p of x, the same y, is equal to q of x. This is linear equation, first order linear differential equation. So if you look at this look exactly like this. My y is being represented with I, while my t is being represented with x. So if you compare this, you will now see that your p of x here, or let me write it, let me use the I and t. Okay, let me use I and t. So it's going to be that the I dt, right, plus p of t, the same I again, is equal to q of t. Okay, so if you look at this, you will see that your p of t, if you compare this equation with this one here, you see that your p of t is the coefficient of the I. And what is the coefficient of I here? The R over L. So my R over L, while my q of t, okay, q of t is simply anything at the right hand side, which is my E over L. All right, now if you have gotten this, and don't forget that in solving the linear equation, the linear differential equation, linear first order differential equation, we need your integrating factor. An integrating factor is simply e raised to power the integral of that p of t dt. All right, which is what? E raised power the integral of what? Your sorry, e raised power the integral of your R over L dt, which is what? E raised power the integration of, this is a constant, and the integration of a constant is just to add the variable. The integration will cancel differentiation. So I am left with r over L t, right? Once I've gotten your integrating factor, your answer is simply I dot integrating factor is equal to the integral of what? Q of t dot the same integrating factor dt. That's just the, go and watch my video on first order linear differential equation. It will help you to understand what I'm saying. So let us now put everything. I'll have that what? I dot what? E raised to power r over L t is equal to the integral of my q. My q is what? E over L dot, by integrating factor again, e raised to power what? R over L t, right? So now, then plus a constant. Now, if you look at this now, I want my I to stay alone. If my I is staying alone, I have that I is equal to, if this one is coming to divide here, it's going to be e raised to power minus R over L t. Okay, it's dividing everybody here. And who is it dividing? E over L is a constant because it does not have t. T is the variable. Okay, E over L, let me bring out E over L. Then I now have my integration of what am I saying? E raised to power what? R over L t dt, okay, plus a constant. So that is that. So that is simply the solution to this particular uh, modeling. Okay, this particular, like, this is the solution. This is the derivation. Anyways, if you're asked to derive it, we are going to solve a question so that you understand it perfectly. But if you're asked to derive it, this is just what you need to do, and you have gotten the answer. But if I decide to continue solving, you see that your I here is equal to what? E raised to power minus R over L t into the integral of this thing is simply differentiate this place and use it to divide everybody. So if I differentiate this, if I differentiate R over LT with respect to t, it's just giving me R over L. If I divide, it means they will turn around. It will now be L over what? So don't forget I have my E over L here times differentiation of this will give you R over L. Divide it will now be L over R. Okay, then repeat E raised to power what? R over LT, then plus a constant. So that is that. You know, so that this will take care of this. I'm now left with this as my final answer. But you stopping here is a good work. You have done a great job stopping there. Okay. So the next one we'll now look at is very, very simple. Right? We're going to solve questions to help you understand it. So the next thing we're going to talk about is a circuit that has resistor and capacitor. Okay, resistor capacitor circuit. Now I have that this is my resistor R, and then my capacitor is like this. Then I now have my EMF, my potential difference. The difference between potential difference and the capacitor is that capacitor, their lengths are the same thing, of the same size, but this one you see that they are not the same thing. This is negative and this is positive, but here they are equal to show that this is your capacitor. All right, so if we still use the same law that we used again, that said that the total EMF, this is my EMF E, or potential difference, so that the potential difference across everything is equal to what? The potential difference across the resistor plus the potential difference across what? The capacitor. So if you remember what I told you, if you remember what I said, that this one is now E is equal to, this one is just IR, don't forget, plus why this one is now what? The integral of what? I dt. Okay, then don't forget that you are putting your capacitor, and we're using 1 over C. We're using 1 over C. Don't forget, check my last video. We're using 1 over C here. So if we have this, what do we do? Let's decide to differentiate everywhere so that we can remove this integration. Okay, if I decide to differentiate everything, I'll be having okay, differentiating everything, or do I replace? Okay, let's decide to differentiate everything. Let's see what we are going to have. with respect to t. We're differentiating with respect to t. So I'm going to have if you are differentiating, I'm going to have the dt is equal to, if I differentiate this place, I'm going to have the I, okay, the I dt having my r, okay, the I dt having my r, okay, plus, if I differentiate this place, I'm going to have 1 over c. Differentiation will cancel integration, so I'm left with just I, or rather I over c. Are you getting that now? So if I arrange this thing very well, it's going to be like this. The mm, okay, let's divide everybody by r. I want the I dt to stay alone. If I divide everybody by r, I'm going to have the I dt, okay, is plus, and dividing by r, I'm going to have 1 over rc, because I'm dividing by with my I, is equal to what? 1 over r de dt. Just do it gingerly. Divide everybody by r, then arrange it very well. That's what I did. After dividing by r, arrange it very well. Now, if you look at this, you see that this is equally first order linear differential equation. First order linear differential equation. Where the same thing we did before. In first order linear differential equation, I have that my di dt, okay, plus p of t, the same I, is equal to what? Q of t. So if you compare this with this, you will see that your p of t is just the coefficient of your I, which is 1 over rc, okay, while your q of t is what? Is now what? 1 over r de dt, okay, de dt. So that is that. Now what we need to get is our integrating factor. So our integrating factor is simply e raised power the integral of p of t dt, okay. You just need to know this formula, which is e raised power the integral of 1 over rc dt, which is equal to what? The integral of t of over rc. Because differentiation cancelling integration, I'm left with t over rc. Okay, this is our integrating factor. So the solution to this question will now be what? I dot integrating factor is equal to the integral of q of t dot integrating factor. So let's do that. I'm going to have I times e raised power t over rc is equal to what? The integral of, what is my q? My q is 1 over r dt, sorry, the e dt, the e dt, okay, then times my integrating factor is now e raised power t over what? rc dt, okay. So that is that. So the last thing to do is just to bring this to this side, okay. Then don't forget plus your constant. So plus a constant. So my I now is simply this one coming here will give you e raised power minus t over rc, then into okay, let me bring out 1 over r outside, is a constant. So I'll bring out my 1 over r here. I'll now have the integral of the e over what? The e over the t dot e raised power t over rc dt plus a constant. So that is the solution to that. See, it's very, very simple. So we are going to be solving some questions to illustrate what we just did, so that it will help us.